The purpose of this video is to discuss the properties of trapezoids and to use those properties to set up and solve equations. First of all, a trapezoid by definition is a quadrilateral with one pair of parallel sides. The idea that it being a quadrilateral is that it has four sides and one pair of those are parallel. Looking at the diagrams below, it says mark the diagrams according to the properties listed. One pair of parallel sides. These would be the pair of parallel sides making a trapezoid. And then let's just look here real quick. If I were to label these, think about the idea of if lines parallel, same side interior angles are supplementary. So what that means is that angle A and D are supplementary and that angle B and C are supplementary. We have no markings for supplementary, short of just saying that they are. Next one says isosceles trapezoid. It has all the properties of a trapezoid, which a trapezoid only has one. It has one pair of parallel sides. What makes it isosceles is the same idea of what makes a triangle isosceles, is it has one pair of congruent sides, and we're going to call these legs. So these are referred to as the legs. Well, I guess that's just a leg, and this is a leg. And then the pair of parallel sides is referred to as the base. So it has two bases and two legs. The bases are parallel, the legs are congruent. So we've taken care of this one and this one. It has two pairs of base angles that are congruent. These are referred to as the lower base angles, and the lower base angles are congruent. These are referred to as the upper base angles, and the upper base angles are congruent. So we have upper base angles as they are on the upper base, congruent. Oh, that got kind of squished. And we have lower base angles congruent. We still have the idea of if lines parallel, then same side interior angles are supplementary. So think about labeling these again. A and D are supplementary, and angle B and angle C are supplementary. So we've taken care of two pairs of base angles congruent. We have the lower pair congruent to the lower pair and the upper pair congruent to the upper pair. And lastly, diagonals are congruent. So let me switch colors. So we have a diagonal from A to C, and it's congruent to the diagonal from D to B. So AC is congruent to BD. I'm not able to mark it here because if you notice these diagonals are not bisected, meaning AC does not cut BD in half because this length up here is visibly shorter than the length down at the bottom. So these diagonals are not cut in half. So I'm not able to mark anything really congruent other than just saying that AC is congruent to B. I think that should be AD. So these are our four properties, which I guess technically five if you consider the adjacent angles, consecutive angles to be supplementary. All right, on to the next thing. So this isn't in your notes, but think about it for a second. It says, can a trapezoid also be a parallelogram? And the answer is no. A parallelogram has two pairs of parallel sides, and a trapezoid by definition only has one pair of parallel sides. If you were to turn back in your notes, and I'm going to scroll back here to this page. If you notice, quadrilateral was this whole idea here, and we started by breaking into parallelogram and then special parallelograms. Trapezoid is its own family branch. It's not related to the parallelograms at all, and again, it's because of the idea of one pair versus two pairs of opposite sides parallel. So no, a trapezoid can never be a parallelogram. So some problems here. It says find the measure of the numbered or missing angles and or the variable. So this particular diagram is an isosceles trapezoid. In an isosceles trapezoid, we know that the base angles are congruent, and we know that the upper base angles are congruent. So that means that angle 1 is equal to 77 because it's congruent to that other lower base angle. Because of the idea of parallel lines, these are same side interior angles, And if lines parallel, same side interior angles are supplementary. So if this is 77, the supplement of 77 is 103. Following on the same idea, if angle 3 is supplementary here, it is also 103. And I have marked that the upper base angles are congruent, which they are. Looking at letter B, this is a trapezoid. Not an isosceles trapezoid because the sides aren't marked. If it were isosceles, isosceles trapezoid, then the base angles would be congruent. But if you notice, these sides aren't marked. They appear to be congruent, but there's not enough information. So I'm not going to be able to set up this equation here because I don't know if it's an isosceles trapezoid. So for this particular problem, there's not enough information. Looking at letter C. So we have that it's marked, so we know that it's a trapezoid. The sides are marked, so it's an isosceles trapezoid. In an isosceles trapezoid, we have 4 or 5 different properties here. So let's see what they gave us. TV is a diagonal and SU is a diagonal. And one of the properties of an isosceles trapezoid says that the diagonals are congruent. So we can set up the equation minus the x. If I add the 1 to the other side, x equals 3. It didn't ask you to, but if you were to plug it in here, that's going to give us 5. Plug it in here, that's going to give us 5 because the diagonals are congruent in an isosceles trapezoid. All right, let's take a look over here at letter D. Lots of variables. I notice I have parallel lines, so it's a trapezoid. I see that the legs are marked congruent, so this is an isosceles trapezoid. In an isosceles trapezoid, the base angles are congruent, so I know this is 70 degrees. In any trapezoid, these angles here are going to be supplementary because of the idea of if lines parallel, same side interior angles are supplementary. The supplement of 70 is 110. It also says that AD, which is this length here, is 5W minus 32, and BC is 2W plus 1. Notice the markings. These are my legs, not my legs, but the legs of the trapezoid, and the legs are congruent because it's an isosceles trapezoid. So since the legs are congruent, go ahead and set them equal. 5W minus 32 equals 2W plus 1 minus 2W plus 3W plus 3W, or I'm sorry, plus 32 plus 32 would give me 33. Well, W equals 11. All right, next section. So now we have another definition, and this is one that isn't totally new. We've talked about midsegment of a triangle and that it goes across the triangle from midpoint to midpoint. The midsegment of a trapezoid does the same thing. It joins the midpoints of the legs of a trapezoid, just like that idea of a triangle. So if here is a trapezoid, and if it's not on your paper, I think it is, go ahead and draw it. Think about taking the midpoint here. We'd know it would be the midpoint if it were marked. And the midpoint over here, this line that connects it, is the midsegment. And by definition, the midsegment is connecting the midpoints of the legs. So these are going to be those non-parallel sides. There are 2 properties, and these properties are similar to that of the midsegment of a triangle. The midsegment is parallel to the bases. So think about this is a base, this is a base. If it's a trapezoid, they're parallel. The midsegment is parallel to it, and it's half the length of the sum of the bases. In a triangle, the midsegment was half whatever the length of the base was. So if this was 6, this was 3. Well, in a trapezoid, there's another base up here now. So it's not just half the one base, it's half the sum of the bases. So let me get that out of the way. So something to jot down on your paper would be this right here, that the midsegment equals half sum, meaning addition, of the 2 bases. So the bases added up. So now let's go ahead and try a couple of problems. It says find the value of the variable, the midsegment, and the bases. So I've written the formula here is that the midsegment equals half the sum of the bases. So the midsegment, let's see here, it says QR is the midsegment. So it's telling me that this thing right here is the midsegment. So that means that these three lines are parallel. And it also means that the midsegment is equal to half the sum of the bases. There was the top base added to the bottom base. So we've got an equation. Let's go ahead and combine like terms before we distribute. So I have 1/2 4x minus 2. Now I'll go ahead and distribute. X plus 2 equals 2x minus 1. I'm going to subtract the x to both sides. So this is 1x. Add this one over here. X equals 3. It's asking that we find the value of the variable, the midsegment, and the bases. So if the value of x is 3, the midsegment would have to be 5. If the value of x is 3, then this would be 12 minus 10, so that's 2. And this one is 8. So look at that. The midsegment is equal to half the sum of the bases added up. So this gives me 10. Half of 10 is 5. So yes, that holds. Last one. The midsegment, let's see what it says. It doesn't tell me what's the midsegment like it did over here, but look at your markings. We have the double marking, so that must be a midpoint, and the single marking, so that must be a midpoint. So this is the midsegment. So the midsegment, which is 15, is equal to half the sum of the bases. So x plus 3 plus 4x plus 7. So I've got 15 equals half. It looks like there's 5x plus 10. I know a lot of you hate fractions, but check this out, and it's a matter of preference. You can distribute and get decimals or fractions, but what if you multiply both sides by 2? You'd get 30 equals 5x plus 10. You might like that a little bit better. If I subtract the 10, I'd get 5x equals 20. Oh, running out of space, so x equals 4. So let's go ahead and find the length of the midsegment. Well, that's done. If x is 4, this would be 12. If x is 4, that would give me 16 plus 7, so 25. And then checking that the midsegment equals, whoopsies, start over. The midsegment equals half the sum of the bases. Oops, that's 23, not 25. So, yep, that equals 30. Half of 30 is 15, so that holds as well. Please let me know if you have any questions. And that concludes the video on trapezoids. Thank you so much.